Right. We have answered in this question up to simple A, Roman number 1, Roman number 2, Roman number 3, and Roman number 4. Right. So we should go, try for the next part of the question. Right. So let me go to next side of the page. Right. So this is the next part of the question. Right. In part B, simple B part, next consider a rotational motion of segment B together with the segment C occurring the round joint 2. The angular velocity time graph is shown in figure 3 for this situation. Segment B rotating about joint 2. What is joint 2, dear? This one. About this point, this segment B rotates with the segment C. So about the point 2, joint 2 mean point 2, the section B rotates. When it is rotating, segment C also rotates. Right. Let's go to the other page. Right. So we came to the page. Next, consider the rotational motion of segment B. I have showed you the segment B together with the segment C occurring around the joint 2. The angular velocity time graph is shown in figure 3. So this is figure 3. What do they ask? Assuming that segment A is held fixed during this rotational motion. So segment A is not moving, only B and C sections are rotated. Actually, the segment B rotates about the point 2. The moment of inertia of the combined system of segment B and C around the axis of joint 2 is 0.01 kgm square. The moment of inertia of the segment B and segment C about the point 2 is given as 0.01 kgm square. Moment of inertia given. Calculate the torque applied by the motor during the first 4 seconds of the motion. So during the first 4 seconds, what will happen there? Right. First of all, say in simple B, whether you have obtained the answer or not, say in simple B, draw this graph here. Say in simple B, draw this graph. And somebody unmute the mic can tell me within the first 4 seconds, what has happened here? What kind of motion is this there? Lamai, this is the first 4 seconds.
Constant acceleration?
Yes, velocity increases. If velocity, this is 4 seconds. If velocity increases, it's an acceleration. What is this height here? Somebody please tell me, what is this height? It is 0.5. Very good. It's given 0.5. Right. Draw this graph. So during the first 4 seconds, angular velocity increases from 0 to 0.5. That's what they have. That's what given in the graph. Right. Now somebody unmute the mic can tell me what has happened to the angular velocity during the last 4 seconds. Lamai, this is the final 4 seconds. Right? 4, 5, 6, 7, 8, 4 seconds. During these 4 seconds, what has happened? Is it acceleration or deceleration?
Deceleration, sir.
It's a deceleration. So please mark during the last 4 seconds, it has a deceleration. Right? Draw the graph and mark these data. So when the graph is with the answers, it's easy for you to understand. If I wish to find acceleration, I have to find the gradient. Therefore, I have to mark these angles. Right? So let me consider this angle as, you can use any letter as you wish. Let me use this angle as alpha. You can use any letter as you wish. And let me use this angle as beta. right? So please mark alpha and beta, right? So to find the gradient, we need alpha and beta angles. So we are discussing this question before we start our new lesson. Complete, dear. Draw it. Draw the graph. Right. So let's find angular acceleration. Angular acceleration during the first 4 seconds. How do I find it, dear? What should I do to find it? In a whether it is angular velocity graph or linear velocity time graph, always angular acceleration is given by Lamai
Tan alpha.
tan alpha. Very good. So angular acceleration during the first 4 seconds is gradient. Gradient mean here tan alpha. So please write this is equal to tan alpha. Can you find acceleration and send you answers to my Zoom chat, dear? Find angular acceleration and send you answers to my Zoom chat. Start. So I'll give you a help. Tan means opposite side divided by adjacent side. The opposite side, height of the opposite side is 0.5. Adjacent side is 4. So what should be this, dear? Lamai? Yes, many of the students send me the answers. I'm very happy. Very good. So 0 divided by 5 is 0. Sorry, 0 divided by 4 is 0. 5 divided by 4 is 1. 4 times 1 is 4. 5 minus 4 is 1. Again, as we have put the decimal point here. For that one, we can convert into 10. 10 divided by 4 is 2. That is 8. 10 minus 8 is 2. 20 divided by 4 is 5. So this is the answer. And do not forget to give the units. What's the unit, dear? Radian per second. Do not forget the units, dear. Because I have seen that sometimes students, they do not write the units. So this is an acceleration, right? Who got this answer? Please raise your hand up. If you have obtained this answer in Zoom chat, please raise your hand up. Very good. Many of you have obtained the correct answer. Right. Now, Roman number 1, calculate the torque applied by the motor B during the first 4 seconds. So what is the answer for B Roman number 1 there? So B Roman number 1, they ask us to find the torque applied by the motor. To find a torque, actually, there are two equations. Which equation is more suitable for here? Lamai, which is the best equation?
Moment of inertia into angular acceleration.
Very good, excellent. So torque equals I alpha. Please write the equation and find the torque there. Start. Send your answers to my Zoom chat. Torque equals I alpha. Torque equals I alpha. So while we are covering the syllabus, it's very important to discuss the past paper questions, but do not forget my new questions tute, right? I have given you 100 questions, 100 new questions for the circular motion tute. Before I give you the next tute, please complete it here, right? So it's a must to discuss both new questions and past papers. Do not forget my tute. If you have not received the tute, I think even I have sent you the PDF and a PDF also, right? Try all the questions of that tute. Right. Torque equals I alpha. I is equal to 0.01. Alpha is, we have found it as 0.125. So what is the answer? The easiest method to simplify this is 0.01 can be written as 1/1000, right, into 0.125. So it means actually the multiplication here 0.01 into 0.125 means actually 0.125 divided by 1000. So what is the answer here? Let me help you further. 1/1000 can be written as, let me help you for the simplification. 1000 can be written as 10 to the power 3. Am I right there? So 1/1000 can be written as 10 to the power 3. Multiply by 0.125. Clear here? So the next step, in the next step, let me take this 10 to the power 3 upward. 10 to the power plus 3 comes up as 10 to the power minus 3. Am I right? Am I right, Lamai? Into, wait, 0.125, Lamai, 0.125. Let me write, please try to understand my mathematical simplification methods. Please try to understand that 0.125 can be written as 12.5 divided by 10. Am I right? Clear or not?
Clear, sir.
0.125 can be written as 1.25 divided by 10. 10 can be written as, look at board carefully, 10 can be written as 10 to the power 1. Am I right? Because some students consider these simplification methods are difficult. That's why I'm giving you this help. 0.01 is written as 1 over 1000. 1.25 is written as, sorry, 0.125 is written as 1.25 divided by 10. Right?
Sir, is it 1 over 100, sir?
Why 1 over? Yeah, yes, 1 over 100. Sorry, it should be 1 over 100. Yeah, 0.01 means 1 over 100. Yes, sorry. That will be 3 with this one. I'm so sorry. With this is 10 to the power 2. Now, okay, right. 1 over 100. Now, are you okay up to this point? 0.01 can be written as 1 over 100. 0.125 can be written as 1.25 divided by 10. 10 means 10 to the power 1. 10 to the power plus 2 comes up as 10 to the power minus 2. Nothing will happen to this 1.25, and this 10 to the power 1 comes up as 10 to the power minus 1. This 10 to the power 1 comes up as 10 to the power, sorry. This 10, what has happened? This 10 to the power 1 comes up as 10 to the power minus 1. Am I right? So finally, what is the answer here? Finally, finally you will get that 1.25 into 10 to the power. This is minus 2. This is minus 1. Altogether minus 3. Unit is Newton meter. Who got the answer up to this level? Who are able to simplify and get the answer up to this point? Please raise your hand up there. Lamai, please raise your hand up if you got the answer up to this level. Very good. Complete the simplification there. Let me move this little bit upward, otherwise it will not be clear for you. Right, complete the answer. Check whether, I think math students, they don't want this much of help for the simplification, but there are bio students also. Even some math students, they are not familiar with this kind of simplifications. That's why I showed you all the mathematical simplification steps. Some students, they don't want, but some students, there are some students, they really need this simplification guide. Complete it there. Right, I'll keep the answer somewhere here so you can complete it. Let me go for the next question. Let me check the next question. Look at board. B Roman number 2. What is B Roman number 2 there? Calculate the angular displacement of B during the 8 seconds of period shown in the figure 3. Angular displacement, how do you find it there? In Roman number 2, it is asked you to find the angular displacement. From a velocity time graph, whether it is angular motion or linear motion, how do you find angular displacement? Lamai?
Right, the area.
Very good. From a velocity time graph, easiest thing to find the displacement is area under the graph. So Roman number 2, please write displacement or angular displacement. Angular displacement equals area under the graph. Area under the graph, please write. Area under the graph. So what kind of a graph is this, dear? Lamai, what kind of a graph is this? It's a Lamai. What is the shape of the graph? Okay. What is the shape of the graph? Rectangle or triangle or a circle? What is it?
Triangle, sir.
It's a triangle. So what is the area of a triangle? What's the equation? That is half into Lamai.
Base into perpendicular height.
Base into perpendicular height. So what is the total base there? If you consider the entire triangle, the base is how many seconds there?
8.
8. Perpendicular height for the entire graph. What is the perpendicular height? This one. 0.5. 8 means this 0 to 8. 8 seconds. Perpendicular height 0.5. 0.5. So 8 divided by 2. Here 4 into 0.5. So what is 4 into 5 here? That is 2.0. Unit is radian. Angular displacement has the unit of radian. Is there anybody who got this answer earlier than me before I explain? Or is there anybody who got this answer at home? Very good. Excellent. So this is the answer for Roman number 3. Complete it there. Shall we go for Roman number 3, Lamai?
Okay, sir.
What about the screen here? Is video clear or not?
Clear, sir.
Okay, thank you. What about others? Is video clear for all?
Clear,
Yes,
sir.
sir.
Yes.
Right. So I'll erase the things that I have written already, and I'll go for next question. But if you want any more time to write the things, please take a screenshot. I'm going to go for the next question. Look at board. So we have found the angular displacement, right? So let me check the next question. Roman number 1 we complete. Roman number 2 we have answered. Roman number 3. If the magnitude of the maximum torque, that can be applied by the motor is 0.002. To rotate the segment B, there is a motor. The maximum torque that the motor is able to apply is 0.02. Unit is Newton meter. What is the minimum time that will take for capital B section, segment B actually, to start from rest, RST mean rest, and comes to rest again after an angular displacement of 3.2 radian? What should happen there? Now what should happen? Look at board. If I draw another velocity time graph, angular velocity and time graph, right? So what's the condition that must be satisfied here? If the magnitude of the maximum torque that can be applied by the motor is 0.02, what's the minimum time that will take for B to start from rest and come to rest after an angular displacement of 3.2 radian? The best thing is drawing a graph. If you have not learned graph, you must send a WhatsApp message to me. So I'll let you know the next time that I reteach this graphs, dear, right? Okay, dear. So you must send a WhatsApp message to me so I can help you to cover the graph section if you have not learned it with me or if you have missed it, right? So let me draw a new graph for the question. So here the velocity is 0, time is 0, and velocity is also 0. So what should happen there? The object should start the motion at rest. The object should start the motion at rest, and it reaches to a certain maximum velocity, and finally it comes to rest. During that, the displacement, angular displacement should be 3.2 radian. This is what I want. This is what we want to satisfy. This is the condition that we want to satisfy. Right, look at board here. Starting from rest, obtain a certain maximum velocity and comes to rest again. Right. So they ask us to find the total time taken for this motion. Look at board here. Here, as earlier, the time period was 8 seconds. How they have divided the 8 seconds here? How the 8 second is divided here? 8 seconds were divided as 4 seconds and 4 seconds. Am I right? Lamai?
Yes, sir.
Very good. So here, let me take this is simple t seconds. And this is simple t seconds. This is also simple t seconds. Then what is the total time taken?
2t seconds.
2t seconds. And here we don't know the maximum velocity. We don't know the maximum velocity. So let me take maximum velocity as, I can use anything. This velocity as omega. I don't know what the omega is. Let me it as omega O, omega M, anything. Okay, right? So the velocity obtained by this is omega M, M for maximum. Draw the graph for Roman number 3. Please draw this graph here. This is for simple being Roman number 3. Draw the graph. Right. So let's try to mark the other thing is we can find angular acceleration here also. Yeah, we have to find angular acceleration. So let me mark this angle as theta radian. Sorry, theta degrees. So please mark this angle as theta, right? Because we have to calculate the gradient. Mark this angle as theta, right? Because first of all, we should find the acceleration, angular acceleration, right? Look at board there. So what is angular acceleration there? From this graph, Lamai? Hello?
Tan theta.
Tan theta, very good. So angular acceleration is tan theta. Can you do the rest and obtain any expression? I think we will not be able to obtain a value for angular acceleration, but we will be able to obtain at least an expression, right? So angular acceleration we cannot find directly, but we can write it as opposite side. So what is this length here? What is this height? This height. What is this height?
Omega.
Omega m. Ne? So I have marked that height as omega m. This height is, please mark this as m for maximum. That is the maximum velocity obtained by the answer. So angular acceleration means tan theta. Tan theta means opposite side. Opposite side. Length of the opposite side is omega m divided by what is this length there? Omega m divided by opposite side divided by adjacent side. Adjacent side is simple t. Write it there. So we have obtained an expression for angular acceleration. Omega m divided by t. Complete it there. Right. So then they have given us the maximum torque value. Can you see that point, Lamai? See, the maximum torque is 0.02. Did you see this, Lamai? Fly girl?
Yes, sir.
Ah, yes. Right. So let me use that equation. Torque equals, what is it? I alpha. Write it here. Lamai, please write. Torque equals I alpha. Now we have alpha mean angular acceleration. We have an expression for alpha. So alpha means this, omega m over t. Am I right, dear?
Yes, sir.
Right. Very good. Others also, please, others also speak there. When students talk to me, I'm very happy. So torque is 0.02. Moment of inertia of section B. What is it there? Moment of inertia of section B with the section C is given as 0.01. Alpha is found as omega m divided by simple t. Write it there. Write it. Omega m is missing. So alpha is omega m divided by t. Can we simplify this any further? What can we do to simplify this further? Think. One of the way to simplify this is this can be written as 2 over 002. So it can be written as 2 over 1000. Am I right there? 0.02 can be written as 2 over 1000. I think you can understand it. And 0.01 can be written as 1 over 10. No, 1 over 100. And we cannot do anything to this omega m over t. We cannot do anything to this omega m over t like this. Complete it here. I'm not going to change the term omega m over t. Right. So finally, I'm just writing the simplification steps. Finally, two of these zeros, this 0 and this 0, can be cancelled out with these two zeros. It means now we have obtained an expression for omega m over t. Now we have obtained an expression for omega m over t. Okay, dear? So what is omega m over t, dear? 2 divided by 10 means 2 divided by 2 is 1, 10 divided by 2 is 5. So what is omega m over t, Lamai?
Acceleration, sir.
No, I'm asking the value.
105, sir.
0.25.
1 over 5, very good. So omega m over t is 1 over 5. Please write it there. Omega m over t equals 1 over 5. That's what I wanted to obtain. I have slowly explained the things because you need to understand it. If I am hurry in teaching, you will not understand the things. So it's useless. I want everybody to understand. So I have obtained an expression for omega m over t. Complete it there. If you want, you can find alpha directly. Alpha will be actually this is actually you can directly find alpha by using Tute equation. Once you find alpha, then you can use the linear angular motion equations. Omega 2 equals omega 1 plus alpha t. Yeah, that is also possible. No problem. Even that method is also okay. But I want to use purely the graph here without using any other thing. Right. So what is angular displacement here? Angular displacement, Lamai? That is area under the graph. Am I right, dear?
Yes, sir.
Right. Area under the graph. Right. So they have given the angular displacement. What should be the angular displacement, dear? Lamai?
3.2 radian.
3.2 radian. Very good. 3.2 radian equals area under the graph. So this is a triangle. So area under the graph means half into base into, what is the base there now? Base is t plus t, ne? T plus t into what is perpendicular height?
Omega m, sir.
Omega m. Complete it here. Let me write it like this because it's very difficult for me to write omega m. So I have written wm. I think you can understand it. So next step, I can take 2 to the other side. Next step, I can take 2 to the other side. Or okay, I'll keep 2 as 2. 3.2 equals, I'll take 2 to this side. 3.2 into 2 equals, this side you have 1 into t plus t is 2t into omega m. Check whether you can understand these things. 102 means area of a triangle. Area of a triangle is half into base into perpendicular height. That's how I got 102 here. So I take 2 to the other side. T plus t is the base length of the base. That is 2t. Right. Now, can you see something like this here? I'm just want to use purely the graph. That's my that's what I want. From this, we can obtain an expression for omega m. What is omega m according to this dear? What is omega m according to this? Just take t to the other side. So it will be t over 5. Am I right? Omega m is equal to just t divided by 5. Check whether you can understand this here, Lamai.
Yes, sir.
Right. What about others? Please raise your hand up if you are okay with this. Omega m equals t over 5. Lamai, please raise your hand up. If you have understood this point, please raise your hand up. Okay, very good. Nice. Now we have the answer. Now you should identify that these two and these two can be cancelled out. You see, these two and these two can be cancelled out. So what are the remaining terms, dear? Here I have 3.2. The other side I have t because 2 cancelled out, and I have omega m. What is omega m according to this, dear? According to this, omega m is t divided by 5. Can you find t from this, dear? Can you understand here? For the omega m, I have used t over m from this equation. Instead of omega m, I have used t over 5. Right. So what is t into t, dear? You can take 5 to this side, then you get, if you take 5 to this side, you will get 3.2 times 5 equals t into t. What is t into t?
T square.
T square. 3.2 times 5. 5 times 2 is 10. You can put a 0 there. 3 times 5 is 15 equals t into t is t square. If t square is 15, what is t, dear?
Square root 15.
Square root of 15. So please complete it here. So finally we get, but this is not the answer, right? Finally we get t equals square root of 15. The unit is seconds, but this is not the answer. What should be the answer?
So it's 16, sir.
Sorry?
Sir, it's 16, right?
Yes. 5 times 2, 10. 1 remaining. Yes, 16. Sorry. This is, sorry. 5 times 2 is 10. You write the 0, remaining 1. 5 times 3, 15. Remaining 1, 16. So what is square root of 16 then?
4, sir.
4 seconds. Please complete there. Is there anybody who got this answer earlier than me? Anyone? Very good. Right. So therefore, what is the total time there? What's the total time? T is only the half of the time. So what should be the total time then? Lamai.
8 seconds, sir.
8 seconds.
8
Very good.
seconds.
Total time is 2 times T. You think? T is 4. And 2 times T can 2 into 4. 2 into 4 means 8 seconds. So I have written so many, almost all the steps because I just wanted all of you to understand the question. So I was not in a hurry when I was discussing questions. Completed here. So this is the complete answer for B, Roman number 3. Right, let's go for the next question. I think we have only one more question to be answered. So that will be there, and it will be the end of this 2012, yeah, 2012 mechanics essay question. So if you want any more time to write the things, please take a screenshot. I'm going to erase everything. If you want any more time to write the things, just take a screenshot. I'm going to erase everything. Right. What is the final thing that they have asked? C, simple C question. Now, segment capital A is allowed to rotate freely around joint 1. What would be the direction of the rotation of segment A? When the segment B starts from rest and rotates clockwise around joint 2. Now the segment A is allowed to rotate freely around the joint 1. Earlier, we have applied brake and we had the mechanism to stop the segment A when B is rotating. What would be, now A is free to rotate. What would be the direction of the rotation of segment A when the segment B starts from rest and rotates clockwise around the joint 2? Give the reason for your answer. So let me check this figure here. According to this figure, if segment A rotates to one direction, if B rotates to one direction, B is rotated about the segment A. If A is free, as initially everything was at rest, do you remember the law of conservation of angular momentum? The law of conservation of angular momentum. Do you remember this? According to this, what should happen here? Initial angular momentum, let me use AM, should be equal to final angular momentum. Initial angular momentum should be equal to final angular momentum. So therefore, initially both A and B were rest. If A rotates to one direction, B should rotate to the opposite direction. I can easily prove it. Initial total angular momentum means moment of inertia of segment A into initially the A was rest plus moment of inertia of segment B into initially it was at rest. Now what has happened? Moment of inertia of A into angular velocity of A should be equal to moment of inertia of B into angular velocity of B. Now you should understand that what is the value of this side there? Initial total angular momentum. What is the value of this side?
0, sir.
It is 0. It is 0. So finally we will get 0 equals moment of inertia of segment A into its angular velocity plus moment of inertia of segment B into its angular velocity omega B. Now if I take this term to the other side, what will be its value here? IA omega A comes to this side as Lamai. Positive
Minus
something
IA omega
other
A.
side. Yes, dear, again.
Minus IA omega A.
Minus. So it should come to this side with a minus sign. That's it. Equals to IB into omega B. This minus sign indicates that rotating direction of B, A and B are opposite. So this is, if you want, you can write this much of a very big description, but no need this much of a description. If you want, you can write this as a note separately. The answer for simple equation is into the anti-clockwise direction. Answer for part C is into the anti-clockwise direction. Reason is because of the law of conservation of angular momentum. Segment A rotates into the anti-clockwise direction. Reason because of the law of conservation of angular momentum. Reason because of the law of conservation of angular momentum. Right? Now, if you want, you can write this note, and that is the end of the 2012 mechanics essay question. That is the first essay question of the paper. Completed, dear. Right. Now I'm going to start a new section that is fluid mechanics, right? So if you want any more time to write these things, you may take a screenshot. I'm going to erase everything and I'm going to start the final section of mechanics lesson, fluid. Right. I think you had more than enough time to write the note. If not, send me a message after the class, then I can send you the screenshot of the whiteboard if you are not able to write the note, the previous note. Right. So for the fluid mechanics, 80 pages single rule CR book is enough. But if you have a circular rotational motion book, if you have more pages in circular and rotational motion book, just divide it into 2 sections and write the heading as fluids. Right. You need some more pages for the circular rotational motion because I wish to discuss more questions, including the first tune that I have given for the circular motion. I think I have discussed some of the questions, but not all the questions. Even there are many past paper questions also. To discuss some past paper questions and new questions, it's better to keep few more pages in circular motion book. Right. So today's heading is fluids. What is a fluid, dear Lamai? What is a fluid? Somebody? If somebody tells you that there's a fluid in a vessel, what does it mean? Okay, write the heading as fluid and write, people were damn silent. So please write the note. A fluid is a common term used for both gases and liquids. A fluid is a common term used for both gases and liquids. A fluid is a common term used for both gases and liquids. That's the simplest definition for fluids. Right. So we have reached to the end of mechanics lesson. Within I think we were disconnected. Right. I think we were disconnected and I think now we have reconnected. So actually I have given the heading as fluids, the final section of mechanics. So please, I have given a note saying that fluid is a common term used for both gases and liquids. Fluid is a common term used for both gases and liquids. This is for both gases and liquids. Fluid is a common term used for both gases and liquids. Write the first subheading. Write your first subheading as density. Density. Right. What is the normal symbol that we use for density, dear? Lamai? You can use two symbols. What is the most famous symbol here? Rho. Most famous symbol is rho. Right. So please write density as your subheading. Within brackets, please write rho. Rho is the symbol that we use for density. Right. Rho is the symbol that we use for density. What is the definition of density, Lamai? Density is the mass per unit volume. What's the equation that we use to find density? Please write them all. What's the equation that we use to find density? O level. Somebody please tell me quickly.
Mass over volume.
Very good. Density is mass over volume. Write it. Density equals.
Mass over.
Very good. Yes. Mass over volume. Write it and please draw a box around it. It's a very important equation. Right. What is the unit of mass, dear Lamai? What is the SI unit that we use to measure mass, and what is the SI unit that we use to measure volume? Lamai? Mass?
Kilogram, sir.
Mass is measured by the SI unit of kilogram. Very good. What is the SI unit of volume?
Meter cube.
Yes, meter cube, cubic meter. Therefore, what should be the SI unit of density? SI unit of density. Yeah.
Kilogram meter per cube. Kilogram per meter cube.
Very good. Kilogram divided by cubic meter. Cubic meter comes up with the minus sign. So SI unit of density is kilogram per cubic meter. Complete this, dear. Write them all. Right, now I'm going to give you an example. This is a very famous example, right? Almost all the teachers give this example. So I also give you this example. So please write. Please write. Two metals of capital A and B are melted. You can heat them and you can melt them. Melted and mixed together. So what is the term that we use for such a thing, dear? If you melt two or three metals, two or few materials, and you mix them together, what's the term that you use to indicate such a material, dear?
Alloy.
Alloy. Very good. So please write that mixture. That mixture within bracket alloy. That mixture within brackets alloy is used to make a solid sphere. Right, please write this example quick. Right, two metals of A and B are melted and mixed together. That mixture is used to make a solid sphere. Right, continue. The density of capital A and B are 4,000 kilogram per cubic meter and 9,000 kilogram per cubic meter respectively. Right? Let me reduce the size of the letters, otherwise I will not have enough space to write the question. Right? So what is the example here? Let me read. Two metals of A and B are melted and mixed together. That mixture alloy is used to make a solid sphere. The densities of A and B are 4,000 kilogram per cubic meter and 9,000 kilogram per cubic meter respectively. Right? Continue. It has been found that the density of the solid sphere is, give me a value, 5,000 kilogram per cubic meter. Right? The mass of A used to make the sphere is MA, and that from B is MB. So question is, find the ratio MA over MB. So this is the question. Would like to try without my help? Lamai, please raise your hand up if you'd like to try for this question without my help. At least a single student. Okay, I'll give you 5 minutes. Give a try. Start. Find MA over MB. Right. So have you found the answers? Can you send me your answers, dear Lamai? So simple, right? The only thing that you want to do is just apply this equation. Just apply this equation. Look at board. We know that density equals mass over volume, right? The thing that you want to do is density of capital A. What is density of capital A, dear? That is also mass over volume. Am I right? Am I? Can you hear me?
Yes, sir.
Right. So density of A, thank you. Density of A is given as 4,000. So density of A is 4,000. Mass of A is MA. Volume of A, it's not given. So let me use as VA, no problem. I can do something like this. Let me take VA to the other side by cross multiplication. Or MA to the other side by cross multiplication as you wish, anything. Right. So if you interchange the terms, right, you will get something like this. VA equals MA divided by 4,000. That's it. So we have obtained an expression for VA. VA is the volume of the material capital A, which is used to make this solid sphere. MA is mass of the material A, which is used to make this sphere. So let me mark this as my equation number 1. Please write whether you have obtained the answers or not. Please write my answers separately. Let me mark this as my equation number 1. Right. Still, we did not obtain the answers. I have just subjected an answer for A. Right. Some student had sent me the answers. Let's see whether the answers are correct or wrong. Then I write the same equation for B. Density of capital B equals again mass over volume. Right. So density of B, that is given as Lamai. What is density of B? 10,000. Density of B is given as 10,000.
9,000, sir. 9,000, sir.
Sorry, 9,000. You are students are still very good. Still students are conscious, right? Good. Mass of B, MB. Volume of B, VB. Right? So just use cross multiplication. Right? Just use cross multiplication. Interchange the terms 9,000 and VB. Then VB can be subjected. Then you can obtain that VB equals MB divided by 9,000. And mark this as equation number 2. This is equation number 2. So we have obtained 2 equations. Actually, we want one more equation. Right. I think you have written the equation. So let me move it away. So I have enough space to write the next part. Right. So the next thing that I'm going to write is density of the sphere. So again, what is the equation there? What is the equation that we should use to find the density of sphere? Lamai?
Mass over volume.
Mass over volume. Mass over volume. Right? So density of the sphere is given as 5,000 kilogram per cubic meter. Now somebody tell me what should be the mass of the sphere? Samai?
MA plus MB.
Very good. To make the sphere, A and B metals are used. Mass of the metal A used is Ma. Mass of the metal B used is Mb. Therefore, the total mass of the sphere should be Ma plus Mb. So similarly, what should be the volume of the sphere? Lamai?
MA over 4,000 plus MB over 9,000.
Yeah, let's use the normal terms. Volume of the metal A is Va. Volume of the metal B is Vb. Therefore, the volume of the sphere should be Va plus Vb. Am I right?
Yes, sir.
Mass of the metal A used is Ma. Volume of that Ma mass is Va. Mass of the metal B used is Mb. Volume of that metal is Vb. That's it. So if you take, if you use cross multiplication, you can take that volume terms to the side of 5,000. So that will be Va 5,000 into Va plus Vb. That is equal to Ma plus Mb. Clear? Okay, dear?
Okay, sir.
Right. So if you remove the brackets, what will you obtain here? This VA should be multiplied by 5,000. This VB should be multiplied by 5,000. Remove the brackets. Right here. Write them all and remove the brackets. Start. Right. So if you remove the brackets, this VA should be multiplied by 5,000 and VB should also be multiplied by 5,000. So then you get 5,000 times VA plus 5,000 times VB equals MA plus MB. Okay. And mark this as your third equation. That's all. Who got this equation? Lamai, please raise your hand up if you got this equation. Right now, the answer is straightforward. So simple. The method is this. We have an expression for VA, we have an expression for VB, we have an expression for VA, VB, and MA. So let me erase this. Let me keep this equation somewhere here. Right. So VA is this, and we have marked this equation as our equation number 1 because I'm going to erase all the other things. And we have an expression for VB. We have marked it as the second equation. Right. So we have expressions for VA, VB, and all the other things. And let me erase this, these things. Right. Look at board. So let me combine these things from 1, 2, and 3 equations. Right. So I'm going to combine the 3 equations. Look at board. Let me write the third equation first. What is third equation here? 5,000 times VA plus 5,000 times VB equals MA plus MB. Now the point here is 5,000 times what is VA here? According to equation number 1, what is VA? Lamoy?
MA over 4,000.
Very good. That is MA over 4,000. Right. Then plus 5,000 times VB. According to the second equation, what is VB? Lamoy?
MB over 9,000.
Very good. MB over, sorry, MB over 4,000. MB over 4,000. And the other side remains unchanged as
9,000, sir.
VB. Yes. MB over 9,000. Yes. MB over 9,000. Yes. Very good. Other side remains unchanged as MA plus MB. Write this and try to obtain the relationship between MA over MB. I think you don't want my help. Right here, try to find the final answer for MA over MB. Give a try. Okay, dear. So what's the answer? Hello. Can you see that these 3 zeros cancelled out with these 3 zeros, Lamai? Lamai. And these 3 zeros cancelled out with these 3 zeros. So what are the remaining terms then? What are the remaining terms?
5MA over 4 plus 5MB over 9.
Very good. The remaining terms are 5MA over 4, right? Plus 5MB over 9. The other side, things remain unchanged as MA plus MB. Now the thing that you want to do here is, right, the easiest thing is 5MA, I'm going to multiply this by a number, and this 5MA also I'm going to multiply by the same number, and MA of the other side I'm going to multiply by the same number, and MB at the other side, MB at the other side also I'm going to multiply by the same number. So it means I'm going to multiply all the numbers, all the terms by a single term. The single term is the product of 4 and 9, because denominator I have 4 and 9. The easiest way to remove this 4 and 9 is I multiply this MA by 4 into 9. This MA also multiplied by, sorry, this is MB. This is MB. So this should also be multiplied by 4 into 9. And this side should also be multiplied by 4 into 9. And this should also be multiplied by 4 into 9. Then what will happen? What will happen if you do such a multiplication? Lamai? 5MA over 4. And here, that board, this 5MB over 9. Now what will happen here? This 4 and this 4 cancelled out. Remaining term will be 5MA and this 9. So what is the remaining term there? 5MA into 9. Here, what is the remaining term there? 5MB. And here the remaining term is 5MB into 9. It's 9 and 4. Because this 9 and 9 cancelled out, the remaining term will be 4. The other side, here 4 times 9 is 36. So this will be 36 MA. And again 4 times 9, 36 into MB. 36 MB. Now 9 times 5 is 45. So next step, 45 MA plus 5 times 4 is 20. 20 MB equals 36 MA plus 36 MB. Now you consider these numbers here. 45 MA is bigger than 36 MA. Am I right? 45 MA is bigger than 36 MA. Am I right there, Lamai? And this, if you consider this 20 MB and 36 MB, 36 MB bigger. So I'll do something like this. 45 MA. I'll take this 36 MA to this side. Positive 36 come to this side as minus 36 MA. And the 36 MB, I do not change it. This plus 20 MB, this plus 20 MB comes to the other side as minus 20 MB. Now, what is the answer here? Finally, 45 minus 36 kiyada lamai? Lamai?
9, sir.
9 MA, very good. 36 minus 20?
16.
16 MB. So just take MB to this side and 9 to the other side. Then you get the final answer as, I'll write the final answer here. Then you get your final answer as MA over MB, because I have taken MB to this side, and 16 divided by 9. Who got this answer here? 16 over 9 is the final answer. Who got this answer? Lamai? That's it. Yeah, some simplification is there, but I think it's not difficult, not so difficult. Even there are some simplifications, but I think it's manageable. Complete there. Please raise your hand up again. Could you please raise your hand up again if you have obtained this answer MAO MB as 1609? Okay, very good. Nice. Excellent. Right. So I think you have written all these things. Do you want any more time to write the things, dear Lamai? Hello. Do you want any more time?
No, sir.
No. Right. So I think you have written all these things. Shall we go to the next section then?
Okay, sir.
Right. I think you have written all these things. Let's go to the next section. If you want any more time to write these things, you may take even a screenshot. So this is a very common example. Even your school teacher will give such an example. Under the fluid section, I'm going to go for the next theory part. The next theory is relative density. Just write the next subheading, relative density. So please write the description. Write the description. The ratio of the density. The ratio of the density of a substance. The ratio of the density of a substance to the density of water, is defined as the relative density of that substance. Complete it, dear. The density of a substance to the ratio of the density of a substance to the density of water is defined as the relative density of that substance. Write it. Right. What is the equation that we use to find it? What substance mean? You will understand once I discuss an example. So what is the equation that we use to find relative density? What's the equation that we use to find relative density? Somebody? Relative
Density of the
density.
substance over density of water.
Very good, very good. It is the density of a substance, or we say the substance, density of a substance divided by density of water. Please write this equation. Right. What is the unit of relative density here? Density of this substance is density of any substance. Substance means plastic is a substance, glass is a substance, petrol is a substance, diesel is a substance, anything. So the SI unit of density is kilogram per cubic meter. Therefore, density of this substance is kilogram per cubic meter. So density of water, the SI unit of density of water is also kilogram per cubic meter. Therefore, what should be the SI unit of relative density? Lamai, what should be the SI unit of relative density?
Unitless.
Unitless, no units, no dimensions. Very good. So let me write that point also. So SI unit of relative density. SI unit of relative density is density of the substance. The SI unit of density of the substance is kilogram per cubic meter. Density of water. The SI unit of density of water is also kilogram per cubic meter. They cancelled each other, then you get no units. Or sometimes in universities we write just as 1, and 1 means no units. Kgm minus 3 divided by kgm minus 3 is 1, so it means no units. Complete there. Please write down everything. Right. Let me try for an example. So please write example. Sample. Please write density. Sorry. What has happened? The density of copper. Density of copper is, please write example. Density of copper is 9,000 kilogram per cubic meter. This is very simple. And that of water is 1,000 kilogram per cubic meter. Find the relative density. Find the relative density of copper. Write the question, write the proper equation, find the answer and send to my Zoom chat. Start there. Find the correct answer and send your answer to my Zoom chat. Start. Right, so method is so simple. Let me use the same equation for this question, right? What's the equation? Relative density. Here we should add something more. Relative density of copper. So relative density of copper is equal to density of the substance. Now substance is copper here. The substance is copper. So relative density of copper is density of copper divided by density of water. So density of copper is 9,000 kilogram per cubic meter. Density of water is 1,000 kilogram per cubic meter. So per cubic meter, per cubic kilogram per cubic meter, kilogram per cubic meter cancelled out. And finally, we got the answer as even the three zeros cancelled out. Finally, we get the answer as 9. So relative density is just only a number without units. Who got this answer? Lamai? Right. Now I want to show you something there. Look at board. Right. So I think you all of you have written the answer. I'm going to re-edit this relative density equation. So relative density within brackets, the other form. Sorry, the other form. So I'm going to give you the other form of relative density equation. Please write your next subheading as relative density, the other form. It means the other form of the equation. Please write there. Please write the heading. Right. Look at board there. Look at board. Relative density of a substance is, look at board here. I'm going to edit this equation. Relative density of a substance mean density of, here now we know the substance. For example, it may be coconut oil or something like that. Relative density of the substance divided by density of water. Please write this equation. No, please don't write, because I'm going to edit this equation. I'm going to edit this equation. Please write this first one and keep some space for the editing. Start. Write the subheading and write the equation there. And we are going to edit this equation. Right. How to simplify this there? Look at board. Density, okay, we were a little bit delayed. Right. We were a little bit late. Sorry. Listen there. Density of substance mean actually mass of the, look at board carefully, don't write, mass of the substance divided by volume of the substance. Am I right there? Density of a substance mean mass of the substance divided by volume of the substance. Right? This should be divided by density of water means again mass of water divided by volume of water. Am I right here? Please don't write. Please tell me whether I am right or wrong. So this is the division symbol. Lamai, please tell me whether I am correct or wrong.
Correct, sir.
Right. If so, please write this step also. If you think that I am right, please write this step also. Right. The next step, look at board dear. Just look at board. The next step will change everything. Look at board. Lamai, can you hear me properly?
Yes,
Yes, sir.
sir.
Right. Very good. Thank you. Now look at board. I don't do anything to this side. I don't do anything, any changes this side. I just write mass of the substance divided by volume, mass or volume, right? Volume of the substance. I do not change. But you know that this division becomes multiplication when we get the reciprocal of this mass of water and volume of water. So volume of water comes up. Volume of water comes up and mass of water goes down. We have taken the reciprocal, therefore division becomes multiplication. Please write this dear. Please write this step also, Lamai. Now I'm going to ask you a question. What will happen? Don't write this. If the volume of the substance, if the volume of the substance is equal to the volume of water, then what will happen? Lamai? Then what will happen?
Cancel out, sir.
Yes, very good. Then the volume terms cancelled out. So what will be the remaining terms, dear? Then what will be the remaining terms? Only the mass terms. Mass of the substance will be, they are divided by, we do not say only mass of water. We won't say that their volumes were equal. We won't say that volumes were equal. Volume of water and volume of the substance were equal. So therefore we say the mass of equal volume of water. Mass of equal volume of water. That's how we write it. So this is the final form of, this is the other form of relative density. Please write exactly the things like this and try to memorize this equation. It's very important. In the examination, they will not ask you to prove the equation. You can directly use it. You can directly use it. No need to prove the equation. So this is the other form of relative density equation. Complete it here. It's better if you rewrite the equation and draw books around it. I think it is very important equation. Therefore, please write the relative density, the relative density of a substance, the relative density of a substance equals, please write this equation separately and draw box around it. Relative density of a substance equal the mass of the substance, divided by the mass of equal volume of water. So it means volume should be equal. Volumes should be equal, right? So please write this equation and draw box around it. Right. Let me give you an example there. Let me give you an example. Please write example. This is also a very common example. Almost all the teachers are using this example, right? So, the other thing is all the school teachers will give you this example. That's why I'm also giving you. So when you go to school, it will be much easier if you have answered this example. So please try it. Actually, this example is talking about a glass vessel which is completely filled with two liquids, right? So please write example. The mass of an empty glass bottle. The mass of an empty glass bottle is 1.2 kilogram. I'm reading the question, therefore you will be able to write it, dear. I'm reading the question. The mass of an empty glass bottle is 1.2 kilogram. Full stop. When the bottle is completely filled with water, the mass, when the bottle is completely filled with water, the mass of the bottle becomes 1.9 kilogram. So what is the example there? the mass of an empty glass bottle is 1.2 kilogram, right? When the bottle is completely filled with water, the mass of the bottle becomes 1.9 kilogram. Full stop. When the same bottle is completely filled with an oil, the mass of the bottle becomes 1.7 kilogram. So the question is, find the relative density of oil. This is the question. Write it there. Everybody please write the question. Right. Somebody please tell me what should be the what should be the mass of water in the bottle? Somebody please tell me, dear. What should be the mass of water in the bottle? How do you find it?
1.9 minus 1.2.
Very good, because mass of the empty bottle is 1.9. When the same bottle is filled with water, mass of the bottle becomes 1.9. Therefore, mass of water in the bottle should be mass of the bottle with water minus mass of the empty bottle. So what is it, dear? 0. Lamai 0.7 kilogram. Similarly, somebody please tell me what should be the mass of the oil in the bottle. Mass of the oil in the bottle. Lamai?
1.7 minus 1.2.
Very good. When the bottle is filled with the oil, its mass is 1.7. Mass of the empty bottle is 1.2. Therefore, the difference here is the mass of oil, that is 0.5 kilogram. Right. So please write. And the other thing is, as the same bottle is filled with water and oil separately, their volumes are equal. Volume of water and volume of oil should be equal. Why? Can somebody tell me the reason? If the volume of the bottle is, let's say, 1 liter. So when the bottle is completely filled with water, what should be the volume of water here?
1 liter.
1 liter. Now you remove water and the same bottle is filled with oil. What is the volume of oil now?
1 liter, sir.
1 liter. So we can write that volume of water equals to the volume of oil. That's it. Let's write this also, because this is also needed. And finally use this equation. What's this equation here? relative density of a substance. Now this is not the sub or a substance, it is the oil. Relative density of the oil equals, what is it here? Mass of the substance, not the mass of the substance, mass of the oil divided by the equal volume of water. Can you do the rest of the calculations and can you tell me the relative density of this oil, Lamai? Use this equation and send the answers to my Zoom chat. And I want the volume, sorry, relative density of this oil. Find it there, everybody. Everybody, please send your answers to my Zoom chat. Right, some of you have sent me the answer. Mass of the oil, we found it as 0.5 kilogram divided by mass of equal volume of water, that is 0.7. So you can take 1 decimal point to the right hand side from both numbers. Then the final answer will be 5/7. Right, so in the examination you have to divide, and relative density does not have units and dimensions. 5 divided by 7 is 0, 50 divided by 7 is 749, 1 remaining, 10 divided by 7 is 1, that is 7, 3 remaining, 30 divided by 7 is 4, 7 times 4 is 28. I think this is enough. Answer up to 3 decimal places enough. Even you keep the answer as a fraction, that is enough for me. Right, so I think that's enough for today.